Here we're going to cover some common issues with sheet metal that we see. This is an exaggerated reason here of what's going on in our example. And so what happens is we have a die that needs to bend this part. And if you model something where it has like a point on it, it's going to fall off the bottom die, and you're going to get some like lobing here, or it'll kind of expand out, because what's happening is there's a V die underneath it that is going on. So let me just kind of show you what that looks like so you can kind of better understand what's happening. So there's a V die like this underneath it. Right, and then if we go ahead and extrude that out, it's just rough just for conceptual reasons. Right, so let's say we're bending it, and this is the bottom die that we're pressing into, and my mouse is showing you where we're pressing it from the top of the press brake. This is going to fall off and start dragging on the surface, whatever that die's surface may be, and therefore you get some like bellowing out right here. So it is important to make sure that you keep enough room on both sides. A good way to go about it, there's a couple common, or what I would consider like, off the shelf dies what we use mostly, and I'll just list them out here. It's a 12 millimeter bottom die, 24 millimeter bottom die, and a 40 millimeter bottom die. From my research, this has been a pretty common setup for a lot of companies, and we have lots of other sizes, but this seems to be kind of the go-to. 12 is obviously for the smaller stuff, 1/8 inch down. This is for the 5/6, not 5/16, 3/16 up to quarter, and then from here we get up to like 3/8 to like 1/2 inch. And what this is these different sizes here are actually the distance between this point and this point. So if you go with a smaller die, let's say it's a 24 millimeter die, a 12 millimeter die will be down here, and therefore we won't have as much issue with this falling out in here. Now, some things that would help kind of fix this, if we still need to kind of incorporate this into our design, is just change how that cut is. So let's say, for example, we kind of give it some extra room, and now we're bending, and when we add that die back in there, now it's not falling off the edge of the die. So that's really important. I want to take a moment to say that because we're majority of these parts are going to be air bent, it is important to make sure that you're using the correct CLR. Not CLR, I'm sorry, the inner bend radius. So this inner bend radius right now is modeled as a 0.0775. That is from our chart. Make sure that you have that down. The K factor is going to be 0.4, but it's less of a concern because that's something we're going to adjust on our end, as we do accept solid files or CAD files in order to quote stuff as well. So you don't necessarily have to send us the DXF where it's all kind of locked into place. So that kind of covers my main concern with press brake bending. There's a lot of different scenarios where you can end up, you can't bend inside of a box, but just keep in mind that this is definitely like the #1 issue that we run into.